L over 2, like make it L over 3.
Yeah, absolutely. And you can also extend it to past that point if you need to. So if I have moment of inertia stick, then I know what the center of mass is going about here. Well, I can also put this at the end of my arm here and move it like that, where the axis of rotation is moved from the center of the stick to now here.
So, if it turns into a capital M at the end.
Yeah, all those actually should be capital letters.
Oh, if you extend it past the ruler, for example,
Yep.
Is it still only measuring the ruler, or is your arm a part of that system now?
If I said, what is the moment of inertia of the meter stick, then I would just do this and only the meter stick.
Think of it like when you
Parallel
have a
axis
necklace
there.
and you're doing this. Like, you're swinging it around your finger. Think of only the necklace as swinging.
There's a problem in the Rube Goldberg test. And there should be something under old tests for test 3 where I point to one and say, this is the Rube Goldberg test, which is one of my favorite tests. Where you have an object, you have a disk. Actually, there's 2 disks there. And then I have a rod sticking out. And it's rotating about that point right there. And the question is, what's the moment of inertia of this? So I have, we'll call it disk 1, disk 2, and rod. The total moment of inertia is the moment of inertia of disk 1 plus the moment of inertia of disk 2 plus the moment of inertia of the rod. The moment of inertia of the disks of disk 1 would be 1/2 m r1 squared, m1 r1 squared plus 1/2 m2 r2 squared plus the rod, which would be 1/12 mass of rod, length of rod squared plus mass of rod times the distance that it shifts, that the axis shifts, which is, and that is getting really cluttered there. Mass of rod, length of rod squared plus mass of rod times the distance that it shifts, which would be half the length of the rod plus the radius of the large disk. So that would be L over 2 plus R1 squared. Hopefully that it gets to the question you were asking. And on the test, I asked, what's the moment of inertia of this? What's the moment of inertia of this? What's the moment of inertia of the rod rotating about its center? What's the moment of inertia of the rod rotating about this point right here? What's the total moment of inertia? And it was the easiest test I've ever had to read.
In what way?
Because everybody skips the questions.
Because I had a spreadsheet of all the answers, of all those solutions, of how to solve it. And if you got this part wrong, then all I had to do is put in that number and it changed all the rest of the answers. So I knew what all the rest of your answers should be, given that one mistake. So all I had to do was input whatever number you put in for your answer, and it would tell me all the rest of the answers. Because every question led to the next question, which led to the next question.
So basically, if you got one mistake wrong, everything else was wrong?
Yes, but you still get an A because I knew what all the rest of the answers should have been given that one mistake.
You just get partial credit for the first answer instead of full credit.
If you ever see on any of the stuff I've handed back, given, that means it's correct given the previous mistake. And you get full credit.
Huh.
Usually.
That looks like
So
it
you
was
care that we get the progress right and not the overall answer.
Say it again?
You care that we get the progress right
Yeah,
instead of.
absolutely. However, if somebody did have the last answer correct, I knew the rest of it had been or they got really lucky. No one did.
No one did it. Yes.
I
Yes.
would say it was my favorite test, it was not the student's favorite test.
Okay.
The psychological aspect did not take into account. But even said, if you can't get this part, use this number for the rest of it.
Is that one full question?
Pardon?
Is it like one question that's split into like multiple parts, like 1A, 1B, 1C?
Yep.
Okay. 1A, 1B.
So in the very first part was, is that 1/2 mass to 1?
I think we should.
Yes,
Is that only mass to 1 or does that include the mass of?
that's only the big disc here.
Okay.
Can you
So it does not
re-explain
include
parallel
that
axis
too.
theorem?
So textbooks will tend to give, and as well as on tests, give the moment of inertia for an object rotating about its central point. The central axis. Now, sometimes it could be different central axes. So if I had a disk, there's one here. Okay, like a hoop. If I have a hoop here, it could rotate about a central axis like that, or it could rotate about a central axis like that.
Right.
Turns out the equation is the same in this case. For a disk, it's the same. I don't know about for a hoop. But if the only difference between what you're trying to find the moment of inertia is and what is given to you for something rotating about its central axis, in other words, all you've done is move your axis of rotation from the center to some other point. That's when you use parallel axis theorem. So it's the moment of inertia about that center of mass, and then you have to take into account the shift. Because moment of inertia cares about how the mass is distributed. The farther it is away, the greater the moment of inertia.
So, what's IP again?
The moment of inertia rotating about this point P.
Okay.
Sorry to go back to what I was asking, the 1/2 M1, so that includes the mass of this too?
No,
So it's like a washer instead of a disc?
yeah, I pictured it that whatever it's rotating about this is small enough that I'm not worried about it. It's rotating about some central axis that is tiny compared to the size of this.
Can I see the diagram?
I meant like the
Thank you.
whole, the disc two, not the center point.
What's your question again?
When you had mass of 1, that's of disc 1, right?
Yes.
Is that, so that includes the mass of disc 2?
No. I had, in the problem, the initial problem, I gave you the mass of the big disk, I gave you the mass of the small disk.
What is
They're on the same axis and they have the same angular speed, same angular velocity, but they are two different objects.
what is with the curly line around the diagram?
That's the object that's rotating.
Is that just some random object?
Yes.
Yeah.
Okay, can I put a circle?
Sure. If that works for you.
The reason why it's like that is effectively show that it can work with any shape. The reason why it's like that is to show that it can effectively work with any shape.
Yes. Questions to
I
hear?
don't actually know. Cause I don't always have this. But I
Alright.
don't use it. I have it in
I'll leave that. Get some of the stuff out of the way. Should be sufficient.
You could definitely have a watch. Oh, like.
You can take a look at this to see if I got it right.
Yeah, so if it were rotating about that point right there, that would be the formula.
Okay. rotating about point C, would it just be like IC equals IP minus MH squared?
Yeah, generally you're given, you know, a formula for IC. There it is. All right, so I have two discs here. And the question is, if I roll them down the ramp, which will get to the bottom first?
Oh,
That's slightly more. Might be what we got. So we're gonna do physics by democracy for a moment. So the big one, the small disk, tie, or neither. I want you to have an opinion. I'm not gonna ask you yet why you have that opinion. So just for right now, gut feeling, which one's gonna make it down first? Who says the big one will make it down first? Who says the small one will make it down first?
I'm getting sort of a hunch, but I'm worried it's gonna be tied.
You know, nothing wrong with being wrong here. So that's 2. A tie?
Can you get rid of the square root on the board?
There's no square root.
And neither?
I say they will fall off the ramp instead of going to the bottom.
What is the question?
Oh, before they get to the end? Let's just make sure that. Okay.
Well, obviously it's not neither.
Neither is they burst into flames all the way down.
Ah, yes.
All right.
Spontaneous combustion.
All right, so let me reword this. Well, actually, I'm gonna say the same thing again, probably. Have an opinion. I'm not gonna ask you to justify it yet, but have an opinion. Gut feeling. Which means there should be 8 votes here.
Big one.
All right, so let's try this again. Who says the big one's gonna make it down first? 1, 2, 3, we now have 4. Who says the small one? Who says a tie?
Can you guess my time?
Pardon?
Can I pick 2?
Can I
Just
finish
pick
it?
two.
She's like, I'm just gonna defy.
Going for that partial credit thing? Neither? Somebody get that.
Yeah, there's 8 votes there.
There are 8 votes there, so thanks to Erica. Erica saved somebody. All right, let's
I
find out
don't
what
vote for
happens.
the big one, I vote for the-
Now, I want to start them at the same time. If there's some board bias, I'll do it twice, once with the small one toward, closer to you, and once with the farther away from you.
Yeah, it'll be first one. Yeah. That's my husband's.
I need something so that we start at the same time.
I agree. Oh,
Here we go.
it's probably, whoa, it's probably wrong. No,
So
it was
tie?
the bigger one.
And it sure looked like a tie to me.
No, it's not. I'm just kidding, I think it was a tie. It's always a tie, like the answer to these questions are always a tie. But look at the bigger
A
one.
little bit of board bias there, but it was close enough. Obviously, they're made of the same material, as best as I can tell. This one obviously is bigger, it's got more mass, but they still got down to this, it was a tie.
The answer is always a tie. And I know that.
Now,
It's always the same thing, This is the other one.
sphere and disk.
I should have counted how many times.
And I keep putting the pins down, but I just use my finger. So I have sphere, I think it's a solid sphere. Sphere, disk, tie. Let's assume, just for the sake of this, that they will not burst into flames all the way down. Have an opinion and vote. Who says the sphere will make it down first? Who says the
That was
disk?
not me. I did
Yeah,
not make
that's
it.
it.
It's me.
Who says the disk will make it down first?
Wait,
I think the sphere is gonna go down first. I should remember.
So 2 for the sphere.
Yeah.
Who says the disc will make it down first?
I think the sphere also.
Wait, is it a solid sphere or a hollow sphere?
I think it's solid.
It's a solid one?
Not
All right.
Oh, then yeah, the solid sphere, right?
Okay. I know, I should have given you some time to think about it. But now that there's been thinking, who says the sphere will make it down first? 1, 2, 3, 4,
Assuming that the sphere
5.
does not fall off the ramp.
Assuming, yes.
Watch
The
it
disc.
Watch it be tied. Watch it be
A
tied.
tie?
I know it's about to be.
Abby, I was just kidding. It's not always a tie.
Either I can't count or someone's not voting.
I didn't. Sphere.
Sphere?
Yeah.
You weren't part of that?
I missed it.
Let's make sure we're going pretty much straight.
It has to be. Look at that.
Okay, the radii are the same. I don't know which one has greater mass.
Oh, well, that would affect my. Guys, we got it right.
So,
Wait, hollow.
You just broke your your stapler off the bottom. Yeah, that's a cute stapler.
good as new. All right, why?
Wait, okay. I don't know if it's correct, but I thought back to the formulas and how the disc, it was 1/12 and the sphere is 2/3.
1/2.
Oh, it's 1/2? Anyway, either way, the sphere is 2/3, which was greater. I don't know. if
No,
that's
the sphere is
2/5.
2/5.
2/5?
If it's solid, it's
If it's a
2/5.
solid sphere, that's why I asked if it was a hollow or solid one.
So the inertia would be small.
Never mind.
But we don't know the masses. I thought I thought the masses were equal, so that's what my thought process
Yeah.
was. That's enough.
I suspect that this is not solid all the way through.
Okay.
This one is what we call a thin-shelled sphere. This one would be a thick-shelled sphere. Which one's gonna get down first?
Is the blue one hollow?
Yes, it's a ping pong ball, or technically table tennis. Sportscraft.
Are they the same
I'm kind of
size?
going for green.
The blue one's a little smaller than the green one.
But the same
I'm kind of
radius.
going for green, I think.
You going for this one? Or that one? Green. Okay, teal and green. All right, so we got green, teal. So green. 1, 2, 3.
No.
Teal. Tie. You're going for tie?
There's one here, so
Hopefully these will not roll
Come
off the
on,
side.
come on.
They seem to want
Let's
to.
go.
Y'all be like don't bet it on it. Y'all put money down on this.
If you're gonna make side bets, now's the time to do it.
We bet on the same thing.
It doesn't matter.
Ow!
I told y'all.
You hurt me.
Why?
You
Because
idiot.
it has
voted for
a
the
thicker
football.
shell.
And?
And it's well, bigger doesn't matter, I think.
If
Because they're both spheres.
they are both spheres, agreed. Why would a thicker shell get it to go down faster?
Is it because it's more dense?
Not quite, but it has more mass.
You hit a magic word, but it's more to it than that.
I mean, it has more mass, which might
Matter.
It has more mass,
because it has a thicker shell.
and also it's a
Bigger.
denser material.
Oh, it is?
But yeah, I mean, I can. Do you want to hold them so that you can see that this one has greater mass?
Yeah.
Were you going to speculate, Erica?
I was gonna say something similar around what they were saying. The reason why I didn't pick the blue one is because it's hollow, and I don't think it would have enough mass to go as fast as that.
If air resistance were a matter,
Yeah.
were an issue, then Yeah, I would agree with that. I'm assuming it's not going fast enough for their air resistance to matter. Where's the hoop that I had earlier? This-
That's enough.
I have two different hoops. This one has more mass. This is, I assume, aluminum, and this one I assume is iron or steel or something.
Oh, weird.
Hopefully not lead.
Arsenic.
Hopefully not that also. All right. So based on your feelings right now, which one will make it down first?
I feel like the black one.
This is a black one.
Because it's a denser material, greater
Well,
mass.
Yeah, and greater mass, denser material, heavier. Which applies to both.
I feel like friction would have to work with this too, right?
Wait, what?
Doesn't friction come into play too?
Friction comes into play that if it's we're pretending it's an ideal roll, that the friction is static and there's no sliding whatsoever.
Got it.
If I made it too steep, and this is the issue with doing a lab with this stuff, if it's shallow like that, it's less likely to slip, but then the imperfections in the board become more of a factor. If I make it too steep, then it's more likely to slip, but the imperfections are less of an issue. So there's sort of a,
Midpoint.
yeah.
So,
Now, I don't know if the difference was board bias. I see one of them.
It's right here behind
Oh.
you.
But it wasn't a significant thing, even though this weighs significantly more. I mean, you obviously
from
picked
my
up-
perspective, it went faster while it was on the board.
it went
Was that-
faster while